For an upcoming Arduino project of mine, I realised I needed an MPU6050 module, which is a breakout board that combines a 3-axis gyroscope, 3-axis accelerometer, and a temperature sensor all into one, and I decided I would entertain myself and have a bit of fun by creating my own Arduino module, as it is something I had never done before up until this point. And now that I have released version 1, I'd like to show you how to use it. Here's how you should wire your Arduino board to your MPU6050 module. There are two ways to download this library. The first one is to make your way to my repository, then click Releases, and under Assets click the source code, that is a zip. After that is downloaded, direct yourself to the Arduino IDE, then click Sketch, Include Library, Add a zip library, then click on that download, and once it is downloaded, in the output it should print library installed. The other way to do it is to go to your library manager, type in MPU6050 and find the one by Ewan Long McKern, which is me. In the setup of all the projects, you must use the wake sensor function and pass in the MPU6050 address. To read the gyroscope, accelerometer and temperature raw values, you must pass the MPU6050 address and also the variables you want the data to be written to. Now that we have the raw values, we can convert them to more interesting values. For example, the gyroscope to degrees per second and the accelerometer to g-force. For these functions, you will need to pass variables that store the raw values and also variables that the function can pass the processed values into. This function converts the raw accelerometer values to g-force values. This function converts raw gyroscope values to degrees per second. Although you don't need to do anything with this information, I thought it would be interesting to note that these values are found by dividing the raw values by the sensitivity scale factor as found in the MPU6050 datasheets. The next functions I'll show you will use terms such as roll, yaw and pitch, and hopefully this diagram can explain what these terms mean. This function allows you to convert degrees per second to pitch, roll and yaw. It can do this as it times dps by seconds to get the degrees, and it accumulates this over time to get the total angle. For explanation and simplicity purposes, let us say that the MPU6050 turns at a constant rate of 40 dps. The dps times the delta time is equal to 10, meaning it turns 10 dps per every iteration. And presuming it's constant, the amount of time turning divided by the delta time is equal to 8. So 8 iterations times 10 dps per iteration is equal to 80 degrees in total. And turning in the other direction makes minus dps. This function converts g-force from the accelerometer to pitch and roll using trigonometry like so. The reason yaw, or the z-axis, is not calculated is because the accelerometer cannot reliably give z-axis values, as the accelerometer bases its values based off gravitational pull, but rotating around the z-axis is not affected by gravity. These functions do the task of calculating the accelerometer offset and the gyroscope offset, and should be called in the setup of the code. They should be calculated at the start, and it should be taken while the MPU6050 is level on a flat surface. The way this works is that angle readings are taken hundreds of times and then the mean is found. These values are the offsets and are used on the rest of the angles later in the code. Finally, to get the most accurate reading, use a complementary filter, which is used to fuse sensor data from the accelerometer and the gyroscope to give a more reliable and accurate reading for your project. Here's a complementary filter that I found and I'm using in my project. Here is the code of the complementary filter in action. All of these functions can be found in example files in my repository, so I will leave a link below in the description for you to find it.